Alrighty, here we go. Literal equations. Check your understanding. I'm going to be going pretty quick because there are like 12 problems and I don't want this to take forever. So the first one, we are solving for y. So I have 2x plus 5y equals 13, and my goal is to get y by itself because it tells me to. All right, so remember our rules. We want to move over the non-y term. So here's the non-y term. It's a 2x. It's a positive 2x. That's being added to the 5y. So the inverse operation is going to be to subtract 2x. Do it to one side, do it to the other side. So I have 5y equals, and remember, these guys aren't like terms. It's a negative 2x, it's a 13, a positive 13. So I can't like add them together and call it 11. That's illegal. So I'll call it negative 2x and a positive 13. And they just sit next to each other like that because they're not like terms. Cool beans. One last step. We have to divide by the coefficient. The coefficient is the number in front of that number that I wanted, or that variable that I wanted, which was y. So let's divide by that number. Let's divide by 5. Cool, cool. So really, I see my answer right here. Y equals that. And we can either leave it as that, or we could write y equals negative 2/5 x plus, and look at that, we got 13 over 5, so I can call it 13/5. So there's two ways. This is a good answer, or this is a good answer. They're both good answers. Cool beans. So it's the same two steps for the first few problems, and there's a reason for that. This is, in algebra, we call that standard form. And what we're doing here is we're taking this standard form and putting it into this form, which we call slope-intercept form. Slope-intercept form. Maybe you've heard of the whole y equals mx plus b thing. We have the y equals mx plus b. All right, so that's going to be really important later on down the road. So right now I'm teaching you how to get ready for it. Up next, we have negative. Oh, that's a highlighter. Let's see. Let's try it again. Negative 3x plus 2y equals 6. And our goal is to get y by itself. So again, it's the same steps. We want to move over the terms that aren't y. So this negative 3x, you're not y. So I'll move it over by doing the inverse, which would be plus 3x. Plus 3x. Boop. And I got 2y equals, and remember, these guys aren't like terms. Don't you call that 9, because it's not. It's a 3x, and it's a plus 6. How do I know it's a plus 6? Because there's no sign in front of that 6, so I know it's positive. And the last step, divide by the coefficient. Divide by 2. I'm going to do it this fun way. That's another way you could do it. And then I see that my answer is y equals, and I have 3 over 2, x plus, and instead of writing 6 over 2, 6 divided by 2 is 3, so I write 3. There we go, looking good so far. So the same two steps on that one. Next, we got 8x minus 4y equals 16. Same two steps. We're trying to solve it for y, so let's move over the term that doesn't have the y in it, the 8x. So the inverse of adding 8x would be minus 8x. Okay? And the reason I did minus 8x is because that was a positive 8x. That is a plus 8x, okay? So that's why I used minus 8x to move it over. And I'll bring down that negative 4y. Just be careful. A lot of people lose their negative sign when they bring this stuff down. And again, not like terms, so I'm going to write negative 8x, and that is a positive 16. Cool, cool. Last step, divide by the coefficient, which is negative 4. Oops, I crossed out too much there. There we go. So my final answer is y equals, that's negative 8 divided by negative 4, which makes positive. 8 divided by 4 is 2. And positive 16 divided by negative 4 is a negative 4. All right, and see how those are all in this slope-intercept form? Okay, it's y equals a number in front of x plus a number. It's muy importante eventually. Moving on, we got negative 2x plus 3y equals negative 9. All right, same steps. Move over the non-y term, so that's a negative 2x, so we're going to do the inverse and add 2x to the other side. And I've got 3y equals 2x and a minus 9. Cool. See, I knew to do minus 9 because it had a negative in front of it. All right, last step, divide by that coefficient, which is 3. And I got y equals, so 2/3 x minus, and that's 9 over 3, 9 divided by 3. All right. Ooh. This one's this finally one that's a little bit different. Those first few were all the same. I'm going to move this like so. So I've got some room to work. Now this one we have, we got that y equals mx plus b, and we're supposed to solve it for m. So I need to move over the other stuff. I'll draw my little line over here. So I need to move, I'm solving for m. That means I'm going to move over the stuff that's not m, which is this b. So I'll subtract b on both sides. All right, see ya. So on the left side, I have y minus b. I don't know what y is. I don't know what b is, but I'm going to follow my rules. And I still have this mx here. And again, remember, we're trying to get m by itself. So m and x are right next to each other, so that's multiplication. So to isolate the m, to get the m alone, we have to undo the multiplication. To undo multiplication, we use division. We're trying to get m alone, so I've got to get rid of x, so I'll divide by x. If I do it on that side, I've got to do it on this side as well. And there's my answer. It's an m equals, and over here I have y minus b, all divided by x. That's one way I could write it. Boop. Here's another way you could write it. Y over x minus, and there's a b over the x as well, so b over x. So boop. Either one of those is a good way to write it. Next one is similar. We're solving for m. So this time I have, this is called point slope form. Y minus y1 equals m times the quantity x minus x1. And we're trying to get m by itself. Now this one looks like it would be confusing, but it's actually like the easiest out of all of these because m is being multiplied by this stuff. So to undo the multiplication, we're going to use division. So we're going to divide by that quantity. Okay, m was multiplied by all that, so to undo it, we're going to divide by all that. They cancel out. Bye-bye. And look what I have here. I have m equals y minus y1 over x minus x1. And that might look familiar to you too, because this is our slope formula. You know, rise over run. That's it. So something that you'll use again in the future. It's the change in your y's divided by the change in your x's. All right, not that we need that right now, but it's cool. It's where we're headed. All right, we got a couple more. All right, so same game, except for now the letters get weird. So we're solving I equals P times R times T. I know these little dots weren't over here because they were just, all the letters were just pushed up against each other. So I know that that's multiplication. And we're trying to solve for P. So we're trying to undo that multiplication. What's cool is you can do it all at the same time. So to undo multiplication, we'll do division. P was multiplied by R and T. So that means we're going to divide by R and T. We're going to divide by R and T. On this side, they're gone. And I'm left with P equals, there's that P all by itself now. And on the left side of the equation, I have I over RT. I don't need the little dot. I can just put them next to each other. There we go. Solved for P. Check. Next, same equation, I equals PRT, which I think that's the interest that you would make on a simple interest. That's what that is. It's simple interest formula. And we're solving for r, so let's get r by itself. And again, it's all multiplication. So to undo multiplying, dude, we're going to divide. Okay, we're trying to undo times p, so let's divide by p. We're trying to undo times t, so let's divide by t. Boop, boop. And if I do it on the right, I better do it on the left as well. pt. So I've isolated the r all by itself right here. R equals, and what's it equal to? It's equal to I over pt. So you notice that these look kind of similar, but they're slightly different. Oh, more similar stuff. I equals PRT, and this time we're solving for t. So let's get t by itself. And again, it's all multiplication, so we undo multiplication using division. What are we dividing by? We're dividing by p, we're dividing by r, so they go away. Do it to both sides. Be fair. And I'm left with t equals I over PR. Cool. So same formula, and we solved for a different variable each time. Cool, cool. All right, the perimeter formula. So some geometry up in here. And we're solving for L. So I've got P equals 2 L's plus 2 W's, and we're trying to get L by itself. So if I'm trying to get L by itself, that means I got to get rid of the non-L. So this 2W doesn't have an L in it, so bye. Go away. Bye-bye. So I've got P minus 2W over here. And then on the right side, I just bring down that 2L. 2L. Okay, and I'm almost there. I just got to get rid of that coefficient, so I'll divide by 2. Now L's by itself. Be fair, do it to the other side. And I've got my L all by itself, and it equals, what is that? P minus 2W over 2. You could leave it like that, or you could have written it as P over 2 minus, and that would be a 2W over 2, which cancels out. So really, it could just be P over 2 minus W. So that's good, and that's good. 3 different ways to write the same answer. All right, getting down to the end, I'm going to move this up. Whew, all right, I'm getting tired. I can do this. All right, we got a equals pi r squared, and we're solving for r. We're solving for, finally, one that's a little different. So let's go with green. A equals pi times r squared, and we're trying to get r by itself. So remember, to do this, we got to get rid of times pi. How do you get rid of times pi? You divide by pi. All right, so on the left side, I've got a over pi. That's weird. It's okay, just go with it. On the right side, I have r squared, and we talked about squares and what to do with them. The inverse of a square is a square root. So do it to both of the sides. So the inverse means it cancels out. So this square root and that square cancel out, which leaves me with just r. And I have the square root of a over pi on the other side. Cool. All right. And our last one, the grand finale, we're solving for f. Let's get some room. Let's do this one nice. All right, let's do it. Let's do it over here. There we go. We got c equals 9/5. We got a big f minus 32 up in there. All right, and we are trying to solve for f. Cool, cool. Now this is going to be something that I don't know if you've ever seen, but I'm going to get rid of that 9/5. There's 2 ways to do this. Do I take the long way or the short way? I'm going to take the short way because you guys are smart. You can handle it. Oh man, you ready for this? With fractions, the opposite of multiplying by 9/5. The opposite of multiplying by 9/5 would be multiplying by what we call the reciprocal, 5/9. So if I do it to that side, I got to do it to this side. It's called the reciprocal. So boom, boom, that gets rid of my 9/5. So now on the left, I've got 5/9 C equals, all right, all that stuff's gone, and I just have F minus 32. We're trying to solve for F, so the inverse operation here is to add 32, add 32. So I did solve for F, and it equals, well, on the left side I have 5/9 C plus 32. Cool, cool. That's the conversion formula for Celsius and Fahrenheit, all right? And that is it. That's how we do it. And you learned something cool. You learned about a reciprocal today. That's cool. Yeah, so have a wonderful day. Make good choices. Bye.